Hi viewers, this is M. Samahadri, lecturer statistics. Today I am explaining one of the important theorem in the probability. It is called the multiplication theorem for n events. Okay, this is the statement of this theorem. So let a1 comma a2 and so on n be the n events such that p of ai is not equal to 0 for all I running from 1 to and so on n. Then P of intersection I running from 1 to n ai is equal to P of e1 into P of e2 given e1 into P of e3 given a1 intersection a2 into and so on P of en given I running from 1 to n minus 1 ai. Okay, the proof of this theorem is this theorem can be proved by by using mathematical induction. Okay, we can prove this theorem. We can prove the theorem prove, prove this theorem can prove this theorem by using principle of mathematical induction, right? We can prove this theorem by the principle of by using principle of mathematical induction. What are the procedure for principle of mathematical induction? There are 3 steps in the procedure. The first step is we have to prove that n is equal to 2, and second step is let us suppose that the result is true for n is equal to r, and the third step is that we have to prove that n equal to r plus 1. There are 3 steps. Okay, the step 1 we have to prove that go to step 1. We have to prove that n is equal to 2. Okay, we have to prove that n is equal to 2, right? What is that? P of, so two events a1 intersection a2 is equal to, what is that? P of a1 into P of a2 given a1, right? How can it possible? Very simple. The right, check the condition probability. Okay, P of a2 given a1 is equal to, what is the formula? P of a1 intersection a2 divided by P of a1, right? So you want P of a1 intersection a2 is the right hand side, P of a1 into P of a2 given a1. Okay, so therefore the result is true for n is equal to 2. Therefore the result is true for what is that? N is equal to 2. Okay, now I'm taking another number, let n is equal to 3. Again check it, that data, and let n equal to 3. So you can take 3 events, that is P of a1 intersection a2 intersection a3 is equal to, so this is separate the 2 terms, a1 intersection a2, this is 1 term, and intersection a3, right? So observe that P of a1 intersection a2, right? P of a1 intersection a2 using 1, what is that? P of a1 intersection a2 using 1, this is equation number 1. Okay, what is that? P of a1 into P of a2 given a1. So P of a1 means P of a1 intersection a2 into P of a2 given a1, it is a3, right? A3 given a1 intersection a2, since from 1, right? So now I'm writing, I'm using again from equation 1, this is P of a1 intersection a2, this is P of a1 into P of a2 given a1, right? The third one is P of a3 given a1 intersection a2, right? So therefore the result is true for n is equal to 3. Therefore the result is true for n is equal to 3 also, right? Next step is second step. Let us suppose that let us suppose that the result is true for let us suppose that the result is true for n equal to r. Therefore p of intersection I running from 1 to r ai. So this is the same as the given statement. Okay, in the place of n write r. So this step is completed. So p of a1 into p of a2 given a1, p of a3 given a1 intersection a2, and so on. P of a are given intersection I running from 1 to r minus 1 a. Right, this is equation number 2. It's very simple. This is equation number 2. Right, so this is the third step. We have to prove that we have to prove that n is equal to r plus 1. Right, n equal to r plus 1. P of consider hand side. P of intersection I is equal to 1 to r plus 1 ai. Right, that is equal to, this term can be separated in two terms. In two terms, I is equal to 1 to r ai intersection ar plus 1. So we have to observe this term P of A1 intersection A2, P of A1 intersection A2. So from using 1, so what is that? P of intersection I is running from 1 to R AI into P of A1 into P of A2 given A1. A2 means AR plus 1 given intersection I running from 1 to R AI. Since from 1, okay, p of a1 into p of a2 given a1, right? Okay, so from we have to observe that equation number 2. So p of intersection is 1 to r ai, okay, right? So this is the equation number 2. Observe that p of intersection is 1 to r ai is equal to, so this, the entire expansion, right, this place. So p of a1 into p of a2 given a1 into p of a3 given a1 intersection a2, and so on. P of ar given intersection I running from 1 to r minus 1 a. Right, this is the p of intersection I1 is running from 1 to r a expansion. Okay, into next term is p of ar plus 1 given intersection I running from 1 to r a. This is the last term, right? So that is equal to, I'm writing same step, p of a1 into p of a2 given a1 into p of a3 given a1 intersection a2, and so on. P of ar plus 1 given intersection I is equal to 1 to, this is written as we are adding plus 1 and subtract minus 1, the value is not changed. So ai, observe that what is that? P of intersection I running from 1 to r plus 1 ai is equal to, okay, so in the place of r plus 1 substitute n. There is I running from 1 to n, ai is equal to p of a1 into p of a2 given a1 into p of a3 given a1 intersection a2, and so on. P of an plus 1, okay, an given intersection a1 to n minus 1 ai. Therefore the result is true for the result is true for The result is true for n equal to r plus 1. Hence, by the principle of mathematical induction, the result is true for all positive integral values of n. Okay, this is the multiplication theorem for n events derivation. Okay, next class we will meet again, new concept. Have a nice day. Bye.